Okay, for your quiz next class, I'm just going to walk you through exactly what you should be able to do. Okay, so first I want to construct an example production schedule. I'm going to go down here. I'm going to make a copy of this and start here. Remember, when we look at production, we're looking at inputs, and in this case my input is going to be labor. And then we're looking at outputs, which really in this case is going to be product. So we're going to look at marginal product, total product, and average product. The rest of the columns over to the right won't be used, but they're there for you just in case you feel like you want them. And to be able to see what I want to see, I need to come back to the assumptions and remember this right here. The law of eventually diminishing marginal returns means that at first production will increase at an increasing rate, then it will still be positive but at a slower rate, and then eventually total production will actually fall. So as I put together this schedule, I need to reflect that. So there I see the first part of that assumption, which is that production is increasing at an increasing rate. So marginal product goes 5, 7, 9, all positive numbers, but 7 is bigger than 5 and 9 is bigger than 7. The next step is we should see it occur that it increases but at a decreasing rate. Still we see increasing production. These numbers are still all positive, but 1 is smaller than 3, is smaller than 5, is smaller than 7, is smaller than 9. So it's this point here that is the highest point of marginal product. Therefore, after that point, we see the law of diminishing marginal returns. Product is easy. We just add marginal product to the previous total product. There's no total product here, so marginal product plus 0 is 5. 7 plus 5 is 12. 9 plus 12 is 21. So up until now, we can see that total product has increased. It increased by a fast rate and then a slower rate, but in all cases it is increased. From here forward, we'll see it decrease. 37 plus minus 1 is 36. Plus minus 3. Average product is going to be total product, and we're saying the average production of each worker. Again, it could be something else instead of labor. It could be shovels, but in this case we're using labor. So we're saying the total product divided by the workers. So 5 divided by 1 is 5. 12 divided by 2. Okay, so obviously all these numbers that come out to more than 3 decimal spots, obviously we're going to round them. So this becomes 3.7 and that becomes 5.29, etc., etc. Okay, now that I've finished constructing an example production schedule, I'm going to do the next step. Remember, with construct, to construct these curves, I'm going to have to use the data that's provided. I can't just sketch them. So whatever I put over here on my graphs has to match up with what my data says. A couple things real quickly. First of all, you notice that I have put 2 graphs top and bottom. Well, that's because when I look at the data over here, the data in the total product column goes all the way up to 37, whereas the highest number in these 2 columns is 7 and 9. So I could put all 3 on the same diagram, but what's going to happen with the differing scale is it's going to sort of distort. The bigger scale of total product is going to distort MP and AP. So I'm going to choose to put them on 2 different ones, but sometimes you do see them on the same one, and that's fine. You see I've labeled output on the y-axes. You see that the x-axes are identical. They both go from 1 to 10, but this goes from, instead of -5 to 10, it goes from 0 up to 37, I promise. As I do this, I'm just going to do it real quickly and fast forward so you guys don't have to get bored. But I do want to point out something with marginal product that I'm going to do first. when I set this up originally, and that was the original assumption, notice each change is only a change of 2. I don't go up 2, then up 3, then up 4, and that's fine. I mean, you could make an argument, but there's no need for you to do it that way. So all I'm going to do, I'm going to start with marginal product, and I'm going to say the first worker, the first input is 1, and the marginal product is 5. So the first worker is 1, and the marginal product is 5. Second worker, marginal product is 7. Okay, so MP is going to look like that. For AP, I'm going to use a different color, but it's really the same thing. I'm going to take my first labor input and put in my AP number. So 1 with 5. And you do note that it's in the same spot. 2 is 6. The ones that are decimals, you don't have to worry about it too much. Just be as accurate as you can be. So again, one of the key relationships that you're going to have to talk about in this is it says show the relationship of MP to AP, okay, right here. So again, the important part of that is that as long as MP is above AP, AP is upward sloping, right? So here, the second dot, MP is higher than AP, so we look at the AP curve, and the AP curve has a positive slope. Okay. Likewise here and here. Now, of course, you do see that MP and AP intersect each other there, and that's from this point forward why AP is downward sloping. Okay. Again, all we're saying is that the new number I'm introducing is less than the average, so of course the average has to fall. Another important thing about the relationship of MP to AP is, yeah, sure, MP will always cut through the highest point of AP, and that's neat, but so what? What's more important is when we come back to the table, when we come back to the schedule and look at average product, again, what we're saying is, what is the average production of each of the inputs, in this case, labor? So, if I'm hiring people, I want them to be as efficient as possible. So they're most efficient when each person is producing the greatest possible amount. So what this highest number of 7 over here correlates to is the fact that this top point of the average production curve is our point of productive efficiency. So obviously that's going to correlate well to the lowest point of the average cost curve, which is also a point of productive efficiency. Construct total product. Again, it's going to be the sum of all the marginal products. So it's going to be 5, then 5 plus 7 is 12, and then 12 plus 9 is 21, and 9 plus 7 is 28. I don't even have to go look over at the schedule to do that. I'm going to do it just to double check. Two things to talk about here. The relationship of MP to TP, and then the second one where it says identify the point of diminishing marginal returns on MP and TP. So the relationship of MP to TP is as long as MP is positive, so from this point back to the left, TP should be sloping upwards. And that might look a little bit wrong, because if I go straight down with that, you see that actually we have a downward slope there. So here's the explanation. We really need to go back to the last positive figure of MP we have, where I drew this little red line. There's actually no data that correlates to that, so it's just kind of in between my data points. So that's why that's happening. So really, if you look here, right, that's the last positive piece of marginal product that we add. So that does correlate straight down to the highest point of total product. Okay, so that's one point that correlates that we need to bring out the relationship of. If we had data for that, you would see that total product would continue to go up, but we don't have the data, so it just is what it is. The second point that is important is if you look at the highest point of marginal product, so this is where the law of eventually diminishing marginal returns kicks in, you can see that on total product as well. And the way you can see it is this first part of total product, if we go over 1 and up 5, right, that would be the slope here. And actually, technically, we probably ought to include that as well. So we went over 1, up 5. The next one, the slope was over 1 and then up 7, right? We went to 12. The next one was over 1, up 9. So the slope was 5, then 7, then 9. So again, that increasing slope correlates to the improving marginal returns. That's the eventually part. Where that changes is right here. So here the slope was 5. Here, the slope goes up 1 and then over, I think, 7 again. So because 7 is less than 9, now we're getting our diminishing marginal returns. So that point also shows a valuable relationship, and they should connect and do right there. Okay, so we've taken care of everything over here except for just this bit here, which is the ability to sketch MP, TP, and AP, and again, to be able to show that relationship that we've already talked about. I'm going to start by drawing two diagrams just right above each other, just like what you see over to the left. Next, I'm going to draw a total product. As I draw it, I'm going to remember that it's steep first, then less steep, and then it starts to go down. Next, I'm going to go from the highest point of total product, and I remember that the highest point of total product correlates to where marginal product cuts through the x-axis. So I'm going to do this. Then I remember the other part of marginal product that I know is that its highest point correlates to where this inflection, I believe that's the correct mathematical term, to where it occurs. So straight up from there, so then I just have to connect these two and finish the MP curve. Okay, finally I have to add in AP, and again that one's really easy because all I have to remember is that it starts with MP and then MP goes through its highest point. And there we have our finished sketch. Of course we're going to do labels and all that sort of thing as well. So that's really it. Those are the skills you need to be able to demonstrate for Friday's quiz, or Thursday's.